Is now recording. Right, here we go. So, last session, we looked at exercises 16C, D, and 17A. But the main thing was these key terms. Average rate of change versus instantaneous rate of change. So can someone remind me again, what is the difference between average rate of change and instantaneous rate of change? Can I please have, let's go into Murphy.
Average rate of change is between 2 points.
Okay, good.
Instantaneous rate of change is 1 point.
Good. So, for those who didn't catch that, average rate of change is, the key point is 2 points. You need something between 2 points. And instantaneous is only 1 point. But what are we looking for? What is it that we're looking for between 2 points? So this one's 2 points. This is 1 point. What are we looking for again? What's average rate of change really? What is that, Mete? It is the gradient. And it's in your notes here. It says simply to find the gradient. So remember back in year 9, to find the gradient, you do need 2 points. So that skill that you learned, average rate of change is just a fancy term for finding the gradient, which is something you did in year 9 between 2 points. And this rule here looks funky, but really that is your y2 minus y1 over x2 minus x1. And I showed you where that came from. Yeah? We'll do an example just below just to re-jot your memory. Instantaneous rate of change is literally, this is what we're actually studying. This is called calculus. It is to find the gradient, okay, at a single point on the curve. Please write that down so know the difference. So one has 2 points to find the gradient, and the one that we're truly studying today, and pretty much this entire chapter, is instantaneous rate of change. Your job is to find the gradient of a straight line with only 1 point on the curve. Okay? So let's do a recap on what you need to know from year 9. So 16C, exercise 16C, so I'm just going to write here to mark it to help you. 16C, exercise 16C, this is an example of an exercise you need to know. You don't have to do all of them, just get the sense of what you're doing because you've done most of this in year 9 already. It's just new wording, yeah? Let's have a look at this. So you can get a question like this, even in year 12. It'll be a simple question on a multiple choice section. They'll say, find the average rate of change. So when you see that, just think gradient. They're saying, find the gradient of this rule, okay, as x changes from 1 to 5. So, if you had to picture this graph, it's a quadratic graph. So I'll draw it on the side just so you can visualize so far. You've got a quadratic graph. And it says from 1 to 5, here we go, I'm just going to draw a line. Say 1 is here and 5's here, so I don't know where it truly is. I'm just making it up right now. We're finding the gradient between this point and that point. So how do you find gradient again? It's y2 minus y1 over x2 minus x1. So first thing is you need the coordinates of these 2 points. You already know this is 5 because they said from 1 to 5. So you know this point, x is 5. This point over here, you know x is 1. But how do you find the y coordinate again? If you know x is 5 and you got the function, it says f of x is equal to x squared, what was it again? Minus 2x plus 5. If you know x is 5, how do you find y? Can I please have Anthony? Yeah, that's it. Because that tells you what the y is. This is y. Back in year 9, this is your x. You know, x is 5. So in the equation, you're finding f of 5. Or another way of thinking about it is 5 squared minus 2 times 5 plus 5. So let's work it out. And that's why I got a little space for you to fill in there. F of 5. So let's calculate it. 5 squared, which we know is 25. So 25. Take away 2 times 5, which is 10. Plus 5. What does that evaluate to? Let's go with Artie. 25 take away 10 plus 5. 20. So that means f of 5 is 20. But what is f of 5? Remember, f of 5 is just finding the y value. So now I've got this point, 5, 20. So this is back in year 9. That's your x value. You can call that x2 if you want, x2, y2. So you got x2, y2 now. Find the other one. So the other one is 1. We need to find the y value. Same thing again. It'll then be 1 squared minus 2 times 1 plus 5. 1 squared is 1. Take away 2 times 1, which is 2, plus 5. What does that equal to? Let's go with Christina. 1 take away 2 plus 5. 4. Is it negative 1?
No.
It's 4, yeah? Yes. So, you got 2 points. 520, 1 and a 4. Yeah, so where did I get the x's from? They told me 1 to 5. So here's my x, 1. Here's my x, 5. How did I find 4 and 20? I just subbed it in to the equation. Now back to year 9 stuff. In year 9, you were given something like 1, 4, and then they give you 5, 20, and they say find the gradient. But back in year 9, this is how you learnt it. You learnt m equals y2 minus y1 over x2 minus x1. That literally is the same formula as what you're seeing here. See, f of b was this one, 5. Take away f of 1, which is 4. So that's just y2 minus y1. And then b minus a, isn't that just 5 take away 1, which is your x values? So 5 take away 1 is x2 minus x1. So this is what you saw in year 9. This is what we're writing in year 11. Same thing. They just look different. Yeah? So answering the question, here we go. That's then 20. 20 take away 4 divided by 5 take away 1. Okay, so I just did 20 take away 4, 5 take away 1, y2 minus y1, x2 minus x1. So you should get 20 minus 4 is 16 over 4, and we get 4. So when they say, what is the average rate of change? The answer is, it's 4. But in year 12, what makes the year 11 and year 12 different? You need to then spell out, well, what does that mean? This 4, what you learnt in year 9 as a gradient is 4 over 1. And it just means that for every 1x movement, so x-axis, 1 unit across, 1 unit on the x-axis, you go up 4 units in the y-axis. In year 12, you don't have y and x, you might have distance and time. So it might be like for every hour, you're going 60 kilometers. So that's speed. Yeah, 60 kilometers per hour. So that's the only thing you have to be careful when you're writing in year 12. We don't just write 4, but we actually write the units. So it could have been 40 kilometers per hour. In this case, it could have been 4 meters per second. All right, so it'll be important to write your answer with the units. Okay, so that's what average rate of change is because you're changing between 2 variables. In year 9, you've got y versus x, and you didn't have to write y and x as units. But once you're doing applications, it matters what your 2 variables are. Is it distance by time? Is it volume by time? What is it? Okay. All right, so that was 16C. That's 16C. Cool. Then we moved into 17A, which was called first principles, and this is a method, a theory to get instantaneous rate of change. Because what's the problem since year 9? In year 9, you needed 2 coordinates. You need 2 points to find a gradient. Year 11 and 12, calculus study, says, can we do it with just 1 point? Okay, what's the technique to get to 1 point? This is the theory. Okay, so I already taught you the theory. Watch my video again if you've forgotten about the theory. I'm going to show you how to do it today. So here we go. Let's start off with this problem. So we're going to follow this rule. Okay, so we're going to find f of x plus h, find what f of x is, subtract them, and then divide it by h, and limit of h approach 0 means make h very small. Okay, let's have a look at this problem here. Let's say I've got an x squared plus 3x. Now, if I drew this graph for you to see, just on the side, x squared plus 3x kind of looks like this. It's minus 3, x-intercept, and 0-intercept. It's a quadratic. They're asking you, what is the instantaneous rate of change? Means the gradient at x equals 1. So let's say 1 is over here. So if 1 is here, then at this point on the curve, what is the gradient of that line. See, before you were looking at 2 points. So it could have been like this, the gradient between 2 points. But now we're looking at only just 1 point. What is that gradient? What is the slope? What's the rate of change at that particular point? Now it's hard to do because you only got 1 point. So how do you do it? First principle says if you follow this formula, and I explained how that went through, and Milena, if you remembered how we were saying if I chose 3, how do we get better? You said 2.1. I said, how do you get better than that? You said 2.01. And eventually we realized the smaller the h value becomes, the closer it is you get to the actual gradient of 1 point. Yeah, so that's the theory. So let's do this. First thing you need is f of x plus h. How do you find f of x plus h? So this is your f of x function. I'm saying that I want to substitute x plus h in. So what should I get? That's the first step in just understanding how to do this problem. What is the first step? Can I please have, let's go with Molly. Do you know how we're going to find f of x plus h? Yeah, very good. So where all these x's are? So like before, when we said f of 5, you would have replaced each letter with a 5. Well, now you're going to replace each of these letters with x plus h. So what does it look like? This is what it'll look like. First one is x plus h squared. Write this down. Plus 3 times x plus h. Can you see all I've done? I've just replaced that little spot there with x plus h. I've replaced this x with x plus h. This is where you do your bit of expansion and simplify it. Because if you simplify it, it makes it easier when you put it all into the first principles formula. So let's expand it. Here we go. This one's easy. 3 times x and 3 times h. So we can say that's plus 3x plus 3h. What's the quick expansion for x plus h squared again? That's back to term 1 stuff. Okay, let's go. X squared plus... Yes, it is 2ab. In this case, a is x and b is h. So it should be 2xh. Very good. Plus, square the last one. H squared. We've expanded them all. So I've expanded the first bracket. I've expanded the second bracket using what you've learned from quadratics in term 1. Let's add them together. What can I add together? Well, there's actually nothing I can add together. Because that's an x squared. That's 2xh. That's a h squared. That's a 3x. And that's a 3h there. But there is something a bit special. What's special about these two terms? This one and this one. What's special about it? They both have an x. So remember, usually in quadratic equations, it's x squared, so ax squared plus bx, and then plus c. That must be your c, because it doesn't have any x's. This one is your x, but since they both have an x, you can factorize it out. So this is what it looks like. X squared. Now if I take this group and I take this group, take out x as a common factor. What goes inside the brackets? X times what gives you 2xh? 2h, very good. So x times 2h gives you 2xh. X times what will give you 3x? 3, very good. So you got 2h plus 3. That's just nicer to see now. And the leftover is plus h squared plus 3h. Now, if this is confusing, you didn't have to do it this way. I just personally like to write it this way because it's more obvious that A is 1, B is 2h plus 3, and then C is h squared plus 3h. So if I had to use quadratic formula, this is nice and easy to see. You don't have to do this step. It was just me doing it because I like looking things neater, but you don't have to do that. Okay? All right. And the next one, funny enough, a lot of students don't know how to fill it in, but what is f of x equal to? It is equal to y. Well, do we have the equation for it? Read the question again. What's f of x? Oh, it's literally here. And that's funny because when we're doing the first principle, a lot of kids can do this, the harder bit. But then when I said, what's f of x? We literally gave it to you. So all you have to do is just write down what you have. It literally is x squared plus 3x. Okay? Now, let's use the first principles. So the rule is just underneath. Here we go. This is our rule. We're going to take whatever you found for f of x plus h, and you're going to minus f of x, and then you're going to divide by h. So let's write it all out. Oh, my screen's freezing. Oh, there we go. All right, here we go. Let's do it. So we've got f of x plus h. Now, I usually like this form, but actually when we're subtracting, it's probably better to keep them in individual terms. Okay, so here we go. I'm going to use this line. I'm going to use this line for f of x plus h because f of x plus h equals this. So let's write it out. We have x squared, well, actually I should write limit of h approach 0 of f of x plus h. So on the top, on the numerator, so write this down, we should have x squared plus 2xh plus h squared plus 3x plus 3h. But then we're subtracting. See, that's f of x plus h. We're subtracting. Ooh. I should have wrote it a bit neater or smaller. That's f of x plus h minus x squared plus 3x. Now be careful when you're minusing here. A lot of students do this. Tell me where they've gone wrong. What's wrong? Because that's f of x. So I wrote it. X squared plus 3x. Here's my f of x plus h. Here's my minus. Why am I wrong already? Something's gone wrong. Very good. Because this comes together. This was one group. So when you say minus f of x, either put in brackets as part of your actual calculation. So it should be minus x squared and minus 3x. If you don't put in the brackets, a lot of students just leave it like that. That's why they're wrong. Because that should have been a minus, not a plus. So very typical algebraic error. Yeah, it's just about your notations. So if you've done that correctly, you got minus x squared minus 3x is you're subtracting whatever f of x is. So you subtract both of them, not just one of them. And then on the bottom, it should be divided by h. All right. Let's see if we can simplify now. X squared, take away x squared. Beautiful. Cancels out. 0. Minus 3x plus 3x. Beautiful. Cancels out. What's left over? We got limit of h approach 0. And in the numerator, we've got 2xh plus h squared plus 3h divided by h. What's beautiful about it? What's so nice about this fraction right now? H's. They all have h. You can simplify it. So you can divide them all by h. So this divided by h is 1. This divided by h is h. This divided by h is 1. This now cancels out to be limit of h approach 0. You have then 2x plus h plus 3. See what I've done there? Or if you wanted to take another step, you can factorize h and then cancel out the h's. But you end up with this. Now notice in your notes, have you noticed that I left this notation here? And I want you to just write a note so that you know, because I didn't mention it in the last class. Notice that I have a little dash on the f. This means the derivative / differentiate, which is another word for saying find the gradient. Okay, so when people put a dash on the function, it means you are now finding the gradient. Because remember, what are we trying to find? Instantaneous rate of change. We're trying to find the gradient of 1 point. So this is the notation to say I'm finding the gradient for that function. Okay, so here we go. F dash of x. Here I'm just going to put it in just so that you know you're actually finding the gradient, because a lot of students lose track of what they're trying to find. So here we go. Let's use the theory of what we talked about last session. If that's to find the derivative, limit of h approach 0, what does this mean? Whoops. What's going on there? Whoops. It's a bit laggy. Limit of h approach 0. What does this mean? What does limit of h approach 0 mean? Can I please have, let's go with Milena. What does this mean again? Yeah, that's it. And that's what we were doing. We were saying this extra h that you're adding on, what if you make it really small, infinitely small? So last session we had 2.1, then 2.01, then I said, what about 2.001? It was getting better and better. So this is saying, well, that little number that you're adding on, what if you make it infinitely small? Now, if that is true, think about this for a second. If this becomes really small, what does this overall add up to? What does it add up to? If this is a very small number, you've got 2x plus a very, very, very small number plus 3, what do you get? If this is very small, I'm going to highlight it again. If this becomes very small, what do you get? Yeah, 2x plus 3. Very good. Because that number becomes so small that essentially you know the answer is just going to be 2x plus 3. Now, that's called the derivative. But remember, we're trying to find a gradient, so shouldn't it have an answer? Shouldn't it just be one number? So, where did you want the number? It said find it at 1, when x equals 1. So this is the rule. This is your derivative. So f dash of x equals this, but this is to find the gradient. Back in year 9. So year 9, you needed 2 points. We didn't use 2 points. We used the theory, and we only need at x equals 1 to find what m equals to. So I'm going to zoom in. This will tell you m. That's what the theory was going to. This will tell you m if h, the second point, was infinitely small. If it's infinitely small, this is the result. But what do I want? I want it at x equals 1. So what does m equal to? It becomes 2 times 1 plus 3. 2 plus 3 gives you 5. So I know in the graph that I drew for you before, in this graph, when x is 1, the gradient at x equals 1, the gradient of that line is 5. And that's a very powerful understanding because you only needed 1 point. Throughout this time, from year 9, 10, 11, you've only always needed 2. Now you don't need 2, you only need 1. What's the problem with this? That took very long just to find m equals 4, 5. Took very long. But it is a skill that you need to know how to do. We don't do that a lot. So 17A, don't do too many questions. Just get a feel of how to do it. So even just if you understand this problem and you pick one more for yourself, that's good enough. I don't need you to practice this over and over because we're going to move on from it. You're going to memorize a rule. Okay? All right. That was a recap of last session. That was last session. So we had 16C, 16D, moved into 17A theory. Cool? All right, let's flip over. Now today's lesson is going to be so much easier. Okay, so that was the theory. Here we go. Flip over. I want you to copy this bit. So for those who did not understand all the theoretical points, that's okay. Learn this. Copy this down for me. Power rule is the first rule that you're going to learn. Power means that you can only use this rule when your function has a power, any power. Okay, so it could be x to the power of 2, x to the power of 3, x to the power of 1/3. If you have a function that is a power, has a power to it, you can use this rule and it will tell you the gradient function rather than doing this. So you did all of this before to get to this point. You can now get to this point without doing all of that because someone out there, some mathematician, has already worked out the proof and it only works for power rules. Okay, so if you want to know the proof, it's on page 576 of your textbook, but you don't need to know that. Here's the rule. Copy this down. If you have a function that has x to the power of n, the rule is drop down the power, so it becomes n times, a still there, times x to the power of whatever the power is minus 1. That's what they figured out. So they used first principles and they played around with the equation and they came to this nice formula. This formula is your shortcut to get there. So I'll prove my point. We're going to do the exact same problem again. X squared plus 3x. Instead of doing what I just showed you before, f of x plus h and then f of x, no, we're going to do this. We're going to use this rule. I'm going to show you how to use it. Here we go. First one. See, this is an x squared. That's a power function. What's the power for x squared right now? What's the power? 2. Now, according to the rule, let's look at the rule again. The rule was, so in this case, n is equal to 2. According to the rule, the derivative will equal to 2. So I'm going to write 2 at the front. A, what's A in this equation? 1. Very good. The number in front of x is 1. So you don't need to write it then. X to the power of, well, n was 2, so 2 minus 1 is 1. That's the derivative of the first one. Let's try the next one. Plus. Let's find the derivative of this one. What's the power of 3x at the moment? 1. So n is 1. Let's use the rule again. The rule says write n. So write n, which is 1. So n is 1. Times a, which is 3. Times x to the power of 1 minus 1. So here we go, 1 minus 1. What does that give you? You get 2x plus 3x to the power of 0. But what's x to the power of 0 again? 1. Look at that. That now gives you exactly the same answer that we got on the previous page. Look at that. 2x plus 3. And this is 2x plus 3. You didn't have to do what we did before. But you had to understand what the power rule means. The power rule is a shortcut to avoid the first principles so that you can get there quicker. So therefore, if you wanted to find the gradient at x equals 1, so instantaneous rate of change, at x equals 1, instantaneous rate of change is equal to 5. Okay, so that's the quicker way. But you need to practice power rule today. So today's goal is to practice this skill. Drop down the power minus the power by 1. Let's have a go with another one. Let's try this one. Now there is a notation. Can you please copy this down? This is Leibniz notation. You don't always have to do f dash. If you have a y, this is what they write. Delta y, delta x means change in y over change in x. That means the same thing. So f dash of x or delta y, delta x means the derivative. Here we go. Let's do it. Let's do the same thing. Power rule. I'm going to zoom out so you can see the power rule again. Let's do the first one. X to the power of negative 2. What is n in this case? Can I please have Anthony? What's n for the first one? Minus 2. So again, according to the rule, let's look at the rule. N is minus 2. So I write minus 2. A, there's no number in front of A at the moment, or x right now, so it's still 1. So times x to the power of negative 2 minus 1. That's for the first one. Let's do the second one. Artie. What's the power for the second one? 3. So according to the rule, this would now be plus, and I'm going to work it out. So 3 times, what's my A here? Let's go with Molly. So n is 3. What's my A? Negative a third. So this should be a negative third times x to the power of 3 minus 1. I'm using the same rule that you're seeing up here. Just the same thing. Find n, find A, sub it in. Let's work out each one. Let's simplify it. Next line, whoops, equals negative 2 minus 1 is negative 3. So it's got negative 2x negative 3 plus 3 times negative a third cancels out to be negative 1. So you got negative x to the power of 2. But we normally don't write plus minus, so you can finish your answer as negative 2x power of 3, power of negative 3, minus x squared. That is the shortcut than doing first principles. So if you did first principles, you get the same thing, but this is quicker. Okay? So far, so good? Yeah, that's the skill. So most students, I've never met a year 12 student who couldn't do that skill because it just becomes plug and play. Find n, find A, sub it in. Yeah? But the times that students might make a mistake is the next two problems. Have a go with these two. I'm going to give you 2 minutes. See if you can figure out how would you do it if you have a fraction, because you got to get rid of the fraction first, Or what if you have brackets? Because I didn't give you brackets before. Have a go with 2 minutes. Let's have a think. I'm going to pause the video. I'm going to write the answer and then check if you've done it right.